Today we're going to walk you through how to start off the M207A and the M205. Let's start with the M207. The M207 is currently configured to 110 input, so that's right over here is your plug. That's your on switch there. Your purge gas in and head gas in over here. The head gas will be the yellow tube. Purge gas will be the green tube. The green tube goes all the way through the unit and straight out. It's basically just there to make sure you remember to put it in. Turn the machine on. Make sure you have your gas engaged. If you don't, there'll be a gas fault that will appear on this unit. Once the unit is on, at least the first time that day, you will need to enter the month, the date, and the year. Simply go to the F keys under each section. So under month, it's F8. So you want to punch in today, of course, is March 25th, so it's 03. Hit enter. The date, the 25th. Hit enter, and the year, always the last two digits, 2014. Enter again. It'll ask you for the time. Time right now, 7:53, so 07, enter, 53, enter, and I just leave the second blank because it's not that critical. This machine comes equipped with a library of pre-welding programs. To access it, you press lib or library. You use the next screen and the previous screen to scroll through the different things. Today we're going to be doing a 2.5 inch pipe. So we just go next screen, next screen, next screen. Menu 4 is 2.5. The wall thickness, as you can see, is 0.065. It's tube type, the material is SS. And this machine has apparently done 283 welds of this type in this corner here. Hit enter and the program is loaded. The M207 uses levels to complete its welding program. Standard program has 4 levels and a downslope. On the 207, the levels are time-based. On the 205, the levels are degrees-based. So in the 205, it would be each level being 90 degrees and the last level being about 110, so you can at least overlap the end of the weld. On the M207, those levels are set by time, and it'll be a trial and error process for you to basically program that. This is the start screen. To access the next screen to see what your levels are going to start at, you hit next screen, and now you see that we are in the level 1. And the time for that level is 44 seconds. The primary amps right here are 60 and the background amps are 29. The pulse for the primary amps is 0.20 seconds and the pulse for the background amps is 0.20 seconds. Now, to scroll through that, you just hit next level and you can see that now we're on level 2. Level 3, and level 4. And you can see the time stays the same, but you will notice that the primary amps drop. Let's show that again. We'll go previous level. So the first level is 60, the next level is 58, the next level is 56, and the next level is 54. And the reason for this is quite simple. As you're welding, it's an enclosed head system. What happens is that you're building energy into the weld and the pipe is getting hotter and hotter. So what you do is you reduce the primary amps by a set amount. I like 2 amps, you may like 3, it all depends on the material. If you're welding 316, you're going to want to go a little cooler because 316, because of the molybdenum content, is a little bit more runny. So what we do is you downgrade those primary amps. Usually by 2 amps, sometimes by 3, again it depends on the material. The one thing that stays consistent though are your background amps over here. You can see these are set at 29. And what that's for is on the back of the pulse, you have a forward pulse where the pulse is full strength, and then the background pulse of the pulse becomes whatever that background setting is. I like to keep it within almost half, maybe a little over. It all depends again on your material. This creates the back of the puddle within the pipe and allows you to actually control your weld width as you go around. Ultimately, you want your weld width to be the same on the front and on the back. Usually it's a little skinnier because you are going through the thickness of the metal. Over here, you can see that this machine says it's ready to test the program that's in it currently. You have basically two settings, and they're run by this button. Ready to test and ready to weld. It's simply a matter of that. Test, weld. It's always a good idea in the field to run at least one test. The head does not fire, it does not pre-purge, it just circles the pipe and makes sure that your tungsten will not have any contact with the actual pipe. And we'll get into that in a little while. So right now we're ready to test. These are your controls for the head that are on the panel. You have your jog buttons for left and right, clockwise and counterclockwise. You have a manual purge valve, which allows you to make sure you have gas flow to the head. It's always a good idea to hit it, and if you do hit it, you'll see in the top of the screen that little LED flashes indicating you have gas. If that little LED does not flash, you do not have gas, and you will end up with a gas fault in this part of the screen. It'll say fault 3. Fault 3 is a gas fault, or it'll say gas fault. It's pretty straightforward. These three buttons here control your sequence. Now, this is your sequence start button. So once you're ready to weld, that's the button you hit. That starts your sequence. If for any reason you have to stop your sequence, you can hit stop sequence, or sequence stop, or all stop. All stop will automatically home the head. So the one minute you hit this button, the head will go back into a home position. And it'll stop the welding process as well. If you're looking to change the program at any time, either you want to increase or decrease the level, or perhaps your weld is too skinny, maybe the metallurgy is a little bit different that day, or any number of factors. You select your level. So we're going to go back to 1. Let's say we want to increase the primary by 2 amps. This is your key on the side. This key has 3 positions. Operate, for when you're in normal operation and not programming. Lock, where you would lock the machine, take the key and walk away if you have an operator you don't trust with your machine. And program, which allows you to make changes to the program. It's quite simple. Under the F keys, you have your positions either for time or for amperage, primary or background, and your pulses, which I would tend not to leave because the 0.20 is actually pretty good looking weld. So if you want to increase time, you just hit F3. Right? It starts to flash. It indicates that it's now ready to be programmed. You can go up, you can go down, and then you hit enter, and it locks the value in. Now this machine has an interesting quirk in that it will only engage the final program once you've run it. So once you've done all of your program changes, leave it in program, execute the weld, ready to weld, start a sequence, do your weld, and at the end of that weld, it'll give you another screen that says, basically ask you if you want to save the changes that you have made. At that point, you say yes or no, depending on how your weld looks. Most times I just say yes because I'm going to change it anyway if it is a problem. But at least, at the very least, your program is logged. If you, for any reason, shut the machine off prior to that little subset coming up saying that, do you want to save the program, all program changes will be lost. But again, like I said, once you've made your changes and you are happy with them, back to operate, and that's it. Very straightforward, very easy to do, not a problem. These are the connections on the right hand side of the machine. This is of course your connection for control of the head. It's an amphenol fitting, it just slots in here, you turn it until you feel a lock and then you can thread it into place. This is your purge gas out. That goes into the other end of your pipe, provides purge gas to the pipe. This is your purge gas down here, this connection here, the silver connection. That's your purge gas connection to the head. Sorry, that That's your purge gas connection to the head. That provides the head with the gas, it allows it to flood the area when it's doing the weld. These are your two anodes. One's your ground, one's your power. They can only be connected one way. It's impossible to get it wrong, so it's pretty straightforward. And everything, of course, leads back into the line of your head. That covers the basic operation of the unit, as far as programming goes and how to turn on the power. Now we're going to get into actually operating the welding head itself and a few critical items. This is your cooling unit. This is the most critical piece of equipment in your entire arsenal. It keeps the head cool while it welds. If you let the head overheat, you'll get a fault for temperature, but also, excuse me, but also you run the risk of damaging the head itself as it can warp. So in order to avoid that, this unit here, with these two tubes, cools this section of the head. Anytime you're in operation and you want to make sure that you are keeping the head cool, just touch that with your hands and you'll be able to tell right away. If it feels cool to the touch, it's cooling and doing its job. If it feels warm, there's a problem when you're cooling. You have to stop what you're doing immediately and check the head for cooling. Okay, let's talk about the head and how to set it up. These are your insertable jaws that you basically use to connect the head to whatever pipe size. They come in different sizes. This one here, you can see, is 2.5 inch. Each one is marked clearly, and they're held in by these screws here, these little Allen screws here. Which is why your most important tool when working with this machine is, of course, a good set of Allen keys. It's imperial sized, and the ones you're going to be using the most are these keys right down here. So let's just go through it. The head swings open, unlatches here, exposing the inner weld area. I'm just going to open that up. Okay, now we can see the actual tungsten. This armature is charged during welding, so don't touch it. You shouldn't actually be in the head at all, but don't worry about that. It travels around in an arc and performs a welding function. Each size of pipe has a different size tungsten. These can either be purchased from AMI directly, or you can make your own using a 1/16 2% seriated or thoriated tungsten. The size of Allen key, a 1/16 Allen key is what will locate tungsten in its socket, and the next size down, which I believe is the 132 Allen key, is what's going to give you your actual clearance. You should be able to just slide it right underneath without any issue. This allows you, whenever you're setting that distance, you can adjust very carefully that tungsten depth off of the metal. Whatever you do not over crank this Allen key. There are problems, they do strip out. You want to keep some extra ones in your toolkit. But you don't need to go overly strong when you're locating it. It just has to be enough to locate the tungsten. It's not under any real force, so it's not going to have any real issue. I'm just going to relocate that head again. And there you have it. Now I'm going to show you what happens when we start a sequence and stop it, and what happens to the head. I'm going to leave this front gate open so you can actually observe it. Now right now I'm going to set myself up and ready to test section, and I'm going to start sequence start. Now, you see the head is starting to move its way around. And I'm going to let it get to a point in its arc, and I'm going to hit stop. Okay, so the button I'm going to hit is all stop, and the head goes back into home position. If I was to hit just sequence stop, it would just stop in that point of the sequence, and then you would actually have to manually reset the head. So we're going to actually set this up and do an actual weld in the pipe. You can't see it in this shot, but I have purge gas at the other end of this pipe. I'm going to lock the jaw. And I'm going to apply some tape just to cover the opening to contain my purge gas here. Now, on a vertical position, I tend to like to leave a little bit on top of my hole for my escaping gas to be as close to the top as possible. Everyone's got their own style, but I find this works best. Purge gas is engaged. Now, it's important to note that there is a pre-purge that the head goes through. It's normally a minute long. I'm actually going to shut the camera off for that pre-purge. As you can hear, the cooling unit is now on. That is the head starting. Arc has been established. It waits for about 3 seconds before it starts to advance the turn. Now we're welding around the pipe. And you'll start to see the circle of light here move its way around. As I said, each one of these is about 44 seconds per leg. So we're going to go through 4 legs and a downslope prior to this cutting. Okay, we're already at level 3. And we have 30 seconds left in the arc. Your time setting is very critical because that is going to discern how long your weld cycle is going to be. On the M205, which I'll demonstrate in a little while, you'll be able to see how it's based on arc of degrees as opposed to the time function like this one here. Because you're controlling every aspect of the weld, you can make the weld look any way you want. Be the puddles shorter or longer. It's basically up to you to control that. As you can see, we're getting back up to the top of the arc. We're now in level 4, and we're about 5 seconds into that arc. And now we're into the downslope phase. You'll see the light slowly fade as it goes down and ends the arc. It's an 8-second long sequence. Again, that is entirely controllable by you when you write your program. And we're into post-purge. When the post-purge is done, you will hear the head cycle back into the home position. And there we go. I'm going to shut off the purge gas. And I'll open the head to show you the weld inside. And there you have it. Okay, so that's essentially how this machine operates. It's pretty straightforward. If you have any questions, refer to the manual. Every step of every operation is covered in the operations manual. Each section is broken down as to how to connect the gas, how to make sure it's connected correctly. And all the system functions and everything. If you have any questions, it's literally in here and it's 5 minutes. If you have any further problems, you can always contact AMI. They will be happy to walk you through any problems. These machines are pretty straightforward. They actually will list everything here on top that you need to do. The programming is pretty straightforward. I've shown you how to do it. You can always refer back in this video to see how it's done. So, good luck. Remember, the cooling unit has to operate the best, and always when you're running. Otherwise, it's just a matter of treating the equipment properly, sanely, and safely. Thank you. Okay, now we're going to talk about the M205. This is lastly upgraded unit from the M207. Each has their positives and negatives. The first thing you're going to do with the M205 is turn it on. The on and off switch is located in the back of the top left corner of the machine. And you engage it and turn it on. Now this program runs on Windows XP and loads its own separate program from AMI. So here we have the start screen. And as you can see, it's broken down into segments. Essentially the ones that concern you are open last, library, and create new. And of course, finally shut down. Setup should only be touched by anybody who's actually a service tech for AMI or someone in our company who's been trained for that. So we're going to go and look in the library first. As you can see, there's a series of different styles of programs in here. Now we're looking for a 2.5 inch. And there it is. So to load it, you just hit the load button and away you go. It loads the program in. As you can see, it automatically puts you into a test situation. If you want to go into a weld situation, you hit weld. So let's look about going into a schedule and having a look at it. So this is the first page. This indicates your pre-purge time, post-purge time, if you have any upslope, which we tend to not have, and how long the downslope is. Now 12 seconds is a little excessive. So we hit that, it calls up a subroutine, we just hit 8 seconds, enter, and now it's an 8-second downslope. Before you start travel on your pipe, it actually holds the head in position for 2.3 seconds while it pulses, building up heat in the weld prior to starting the rotation. And it's telling you that the direction of travel for the head is clockwise. Now you can set it to counterclockwise if you so wish, but clockwise is fine. So we're going to go to the next screen. Now the next screen covers the actual parameters of the weld. So what you have is you have your levels are all indicated, and this weld has 4 levels. Each level is essentially 90 degrees. So level 1 goes from 0 to 90, level 2 from 90 to 180, level 3 from 180 to 270, and level 4 goes from 270 to 364 degrees, which means that it goes 4 degrees past the start of the weld. I actually prefer to give it a little bit more, so let's make that 370. You don't need to have your tail off look shoddy. So you see automatically underneath it tells you how many degrees are each area. So we have 90 degrees for all 3, and then of course the last one is 100 degrees. Now it's set its primary amps at 81.2, which seems high, but the head travels pretty fast. So we'll try it out and see what we get. If you don't like the heat, if it's too high, there's an easy way to do it. You can either go plus or minus 1%. And as you can see, it decreases the head or increases it as you so wish. Okay. And then you would just literally hit run, and it would save that program and go into that. Actually, what it would do is it holds it in current memory. If you lose power, you will lose those program changes. To save the program, you have to go all the way back to the library and save it within the library. Background pulse is set at 19.5 amps. And again, same thing goes for that. And you can increase or decrease. I prefer, say, 22 amps, even 24 amps, let's say 23, enter. Now the unfortunate thing for background is you'll have to do this for all of them. Okay, we go back to run. And if we go to home, we should be able to go back into the library and see if our changes were saved. So let's do that. Here it is. Load it. We'll just check our schedule. And as you can see, the changes were maintained. Going back to run. Every day at the start of your day, you should calibrate the head. Anytime the machine is moved over any great distance, you should calibrate the head. That's handled by this button here. On the M207, the head calibration is automatic and built within the system. And in order to actually calibrate that head on the M207, it's quite an involved process. On the M205, it's handled by the computer. So the first thing you do to calibrate the head is you'll hit calibrate, and it'll ask you to basically make sure that the head is safe to rotate. You want to have no obstructions at all that could impact the tungsten. Nothing that could cause any issue with the head. As you can see, this is an 84000 head. Both the 207 and the 205 use an 84000 head, which essentially means that the head's going to accommodate up to a 4-inch tube. So what you first do is we're going to check and make sure the head is clear to rotate. I see no obstructions in there. So I'm going to hit start on the control panel, as you saw on the last screen. The first thing it does is detect home, and then it does a quick circuit around. That's the first rotation. Now it resets it and does a slower second rotation to finish the calibration. Now at this stage in the game, because you are not applying any kind of temperature, you're not required to have the cooling engaged. Once you get into the welding mode though, cooling will be critical. I know the calibration takes a little bit of time, but it is worth your while and basically worth it to your welds to take the time to do it every day. Just do it first thing when you fire the machine up and you won't have any problems. Okay, that's the completion of the calibration cycle. Alright, so now we're ready to try weld. Same as procedure basically as the 207. We're going to close the gate, lock the head in position, take off the end of the pipe. I've already set my purge gas going into the pipe. Check the schedule, I think it was 50 seconds. Let's see, clicking the weld, and get started. So as you see, it's counting down the pre-purge. That's the arc, there's a delay. Now the head starts to move forward. And you get a nice handy indicator on the screen as to where in the weld you are. Also the bottom, this indicates your rate of travel and your volts and amps. So as you can see, it goes high, low for each one, because that's your primary amps and your background amps. And as we near the top of the amp pipe, see we're getting close to that overlap. And there's your 10 degrees, and now we're into the downslope of 8 seconds. And we're into the post-purge. The head resets, and once the head is reset, we go back into the standby screen, and there you have it. That is completion of the weld. And have a look at our external weld. And you can see it's quite fine. It has good penetration and nice burn line. Let's talk about programming a new schedule. Go back to home. Alright, we go into the create new, and it's going to ask you for a weld. So we're going to tell them this is going to be another 2.5 inch pipe diameter weld. Now you usually have to check and see what's been taken within the library or what assigned to you. So we're going to go name, and we're going to say 2.5 and step. We're going to make this a step program. It's an inch. Alright. Return. The diameter of the pipe is 2.5. The wall thickness is 0.65. And the material is 316. I'll say 304. The weld head model is an 84000. As you can see, there's a variety of heads you can choose from, but the one we want is the 84000 right there. Okay, so then we go to the next thing. Auto step travel, not auto continuous. Because we're doing a step program, we want this to be in steps. So we hit auto step, it loads the program. Okay, and now we start looking at the program itself. So we go to the schedule. Pre-purge 50, post-purge, realistically it doesn't need to be that long. Let's make it 25 seconds. Downslope again, we don't need 12 seconds of downslope, we'll make it 8 seconds. And we'll go to the next one. This gives us into our levels. So as you can see in a step program, 90 degrees of arc with an extra 8 degrees at the very end. It's not too bad, I'm going to leave it at that. It's telling me that for 2.5 inches it wants to start at 54.5 amps and end up at 46.7 with a 16.3 background amperage. Now, my experience has been that the programs in this that are pre-programmed run a little cool, so I usually tend to bump them up. I think for 2.5 inch we probably want to start at around 57. So we'll go 57.3 and then it steps down there. The background amps, I think we need to actually set a lot higher than 16.3. Let's give it 24. Now it should be noted that step programs usually take a lot longer than the continuous programs. So keep that in mind when you program them. They do give a much more, sometimes I feel if you want a more robust looking weld, they give you a little bit wider bead. They're almost my go-to, but it's, again, everyone is different, and whatever you want to achieve as far as a welding style goes, it's up to you. So we're ready to roll. So we're going to hit run. It's going to automatically save that program for me. Back to weld. And we'll set the head up again. Just to save you the pain of waiting through the pre-purge, I shortened it down. So there is the arc being initiated, the delay, and we're into the weld. Now, because the 205 uses degrees of arc, it automatically calculates how long each level is going to be. So you really just have to enter the degrees of arc, and the computer will do the rest for you, which makes it a lot easier on you.
Minutes now when you're back. This case,
There's the downslope and the post purge, and the head returning to home. Let's see what we wrought here. A little bit more heat because it's pretty fresh, but you can still actually engage pretty quickly. And as you can see, it's a much wider weld, but equally as clean as the other one.